I'm Oliver Cabrera and I'm the safety officer.
Hi, I'm Jasmine Tun.
I'm James Honeyman and I'm the team leader.
And this is the continuous distillation lab.
In this lab, you'll be operating a distillation column, and the primary objective is to determine how accurate the reflux flow meter is, and you'll do this based on the data that you collect. You'll do some column calculations and input them into HYSYS and compare the value that HYSYS is giving compared to what you determine experimentally. So just like any lab, in order to enter you need proper PPE. This includes safety goggles, and if you're going to be dealing with a chemical such as the sample analysis, you'll be needing gloves, as well as long pants and closed-toed shoes. Or in my case, the boots of shame. So some equipment hazards in this lab, you want to be sure that none of the equipment runs dry, you want to make sure none of it overflows, and in the event that one of these situations does occur, you'll want to change the controls appropriately. For example, with the reflux drum, if it begins to overflow, there's a reflux control valve there, and you'll want to open it so some of the fluid can drain down. As well as, because there's a reboiler in the system that poses a burn hazard, you want to be sure to stay away from that area to not burn yourself, but this also applies to when you're collecting samples out of the accumulators. Those samples could be hot, so you want to be sure to be careful when you're handling those. In the event of a spill, either from samples spilling over, you want to be sure to clean that up, or if there are leaks in the pipes and there is a big mess, you'll want to use the mop to clean that up and put out a wet floor sign. Because there's pumps in this lab, there's rotating hazards, so if you have long hair, tie it back, keep loose clothing away from rotating parts.
Hi, I'm James Honeyman and...
James, get out your gum!
Sorry. The feed, there's two feed tanks that are, the feed is pumped to the column, it flows first to this control valve, which is controlled by the flow meter here. This is something we set during the lab. It is then sent to this preheater. Once it's heated up, it could go through any three stages, which is the top stage, middle stage, or lower stage. However, the way that we run the lab, this top stage is where we actually are feeding it only. There's also corresponding temperature thermocouples at those spots as well. Once the distillate comes out the top, its temperature is red right there as the inlet, as an inlet to the condenser. The condenser is a shell and tube heat exchanger. It has cooling water. It has a flow meter, an inlet and an outlet temperature for the cooling water, and a control valve for the cooling water that is controlled by the outlet distillate temperature right here. Now once the distillate condenses out of the heat exchanger, it then goes into the reflux drum. This reflux drum has a level transmitter here that controls this control valve here. This control valve controls the flow of the reflux going back into the column. We also have a control valve here that is controlled by this flow meter here. We can control the distillate flow rate being pumped into the distillate accumulator here. Now for the bottoms product, the bottoms comes out of the column into this reboiler here. The reboiler consists of one temperature transmitter, one pressure transmitter, and two level gauges, or level transmitters. The first one is just a main level transmitter within the tank, or within the reboiler. The second one has, transmits the level of, there's a baffle in here that once the liquid level flows over the baffle, it accumulates on the side, and once it reaches a certain height, it flips the switch that turns on this pump. This pump will then pump some of the bottoms product to here, which is the bottoms accumulator. The rest of the boiled up product will then reinsert the column here. That is the apparatus for the continuous distillation column.
Now you want to make sure that the column is prepared for startup. First you want to make sure that the reboiler power is disabled, and then you want to make sure that the distillate pump and the feed pump are disabled. The bottom's feed pump can stay enabled. The reboiler power and the feed heater power should be at 0%, and all of the flow and level control loops should be in manual mode with an opening at 0%, except the condensate temperature control, which should have an opening of 5%, and also the set points for each control loop should be what they are given in the table in the lab handout. Before you start up the column, you want to make sure that the reflux drum level is below 8 inches. If it's not below 8 inches, you'll need to turn on the distillate and reflux pump, and then make sure the control loop is manual and set the opening to 50% and let it drain to below 8 inches. Once it's done that, you can disable the pump and then put the opening back at 0%. Once it's below 8 inches, you can start to start up the column. The first thing you want to do is enable the reboiler power and then set the power to 100%. Once you've done that, you should enable the feed pump, open the feed pump control to 30%, and then put that loop in automatic, and then you'll want to change the feed heater power to 100%. Once that's done, you need to keep your eye on a couple of things. The first one is the condensate temperature. If it exceeds 160, then you'll need to change the OP 5% for every 5 degrees past 160. If it rises slowly, wait until it reaches its set point of 170 and then change the loop into automatic. You also need to watch the reflux drum control level. If it gets above 8.5, then that would be the point where you start the distillate and reflux pump. And then you'll change the reflux drum control to an opening of about 30% and set the loop to automatic, and then change the distillate flow control opening to 40% and set that loop to automatic. After you've done that, you can change your reboiler power to your assigned power. Once you've done that, the column is starting up and will eventually reach steady state. That should happen when the distillate flow is about 50 cc's per minute and the reflux drum level is about 9. Once the column has reached steady state, you'll need to send someone into the lab to take measurements from the tanks and then close the valves that drain the bottoms and distillate into the feed tank. Once you've done that, you'll want to start the flow accumulator. Immediately after they have closed those valves, you should reset it and then start, and then it'll start averaging all the flow rates that it takes in the system. For shutdown, for automatic shutdown, you can just click this emergency shutdown button, but for manual shutdown, you enter 0% for the reboiler power and the feed heater power, and then disable the reboiler power. Then you wait for a minute and you set the feed flow controller to manual mode and set the OP to 0 and turn off the feed pump. Once you've done that, you wait for the condensate temperature to fall at least 5 degrees below the set point, and you wait for the level in the reflux drum to fall below 8.5. Then you can turn the reflux drum level controller and the distillate flow controller to manual and set both of the openings to 0%. You go ahead and leave this enabled, and the cooling water, you set that flow loop to manual and open at 5%.
Most of the data that you'll be collecting will be from Honeywell. You'll want to record flow rates and temperatures. For flow rate, you'll want to record the cooling water flow rate, the reflux flow rate, the feed flow rate, the bottoms flow rate, and the distillate flow rate. As for temperature, you'll want to record the reboiler temperature, the overhead temperature, cooling water inlet and outlet, the feed temperature, and the condensate temperature.
Now during the experiment, you have to come in here and get samples from the column. Now the distillate sample comes out here. You simply open this needle valve and you get the sample from there. The bottoms distillate sample comes from there, and here is where you get the feed sample from. Now once you have these samples, you then analyze them using either the spectrometer or the GC.
Design of experiment principles will largely be abused in this lab because you are only using 2 different reboiler powers, because each set takes about 2 hours to collect samples, so it's really hard to do more than 2. Because of that, you can't randomize between the 2 reboiler powers, and you can't repeat any of the runs. The only design of experiment principles for repetition that is incorporated into this experiment is through the choice that you make for sample analysis, whether that's through refractometer or the gas chromatograph.
I'll be talking about calculations that you'll be doing in the post lab. And here we'll be using HYSYS predominantly. First, you'll set up condensers where you have your cooling water inlet, where you'll put in your temperature and your pressure given from whatever the flow rate is, and then input your flow rate that you'll be getting in GPM, and then do that for the cold water out. You'll be putting the temperature you gathered as well. And then for the vapor 1 will be your tops of the... First you'll put in your composition that you'll get from sampling, and you'll get the temperature and either the pressure or the vapor phase, whichever one will get this to work. And then you'll put in your temperature of the condensate, and you'll gather your liquid flow rate, and with that you'll be able to calculate your reflux ratio using the condenser only. For the condenser, first you'll make a feed stream with and put in your compositions for the 2-ethoxyethanol and water, as well as putting it at relatively room temperature and atmospheric pressure, and putting in your flow rate of 100 cc's per minute. And then you'll run it through your preheater, and you'll input your preheated feed. You'll either have your temperature that you gathered from your from the Honeywell system, or you could put in, for the heat exchanger, the preheater power, which was 2 kilowatts. And then from there we go to the distillation column, which you'll create your flows, total condenser, bottoms, reboiler, and put in the pressure as atmospheric as many places you have to. And you'll put in the number of stages, which should be roughly close to 10, as well as wherever the inlet stage is, depending on what orientation the setup is for the distillation column. And then for specs that we'll use the distillate rate as well as the duty. Normally we'd put whatever our actual distillate rate and duty were, but in order to get this converged, we'll either change the distillate rate by, in this case we increased it from 50, or the duty, which in another case will decrease from 12 down to 5 to get it converged. And from there we'll gather our bottoms, and we can see from here what the composition is of the 2-ethoxyethanol in the water, as well as from here we can calculate the reflux ratio, either by taking the rate of the distillate or by looking up on the reflux ratio here. You can calculate the reflux ratio using your Honeywell data by taking the reflux rate in cc's per minute and dividing it by your distillate rate to get your reflux ratio. You'll want to do a mass balance using the measurements from your 2 feed tanks to see how much goes in and how much goes out, as well as based off the Honeywell data you'll want to calculate the mass balance to compare to see if any of the flow meters are running too high or too low.